The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called Galaxy. And today, we invite you on an exciting journey across it. There is evidence that the observed object's structure is quite unusual. A black hole may also be detected thanks to the gravitational microlensing effect. This involves detecting the massive invisible object as it transits between the Earth and a remote star. This changes the star's spectrum in a special way. But admittedly, this method requires a number of rare factors to successfully work. There is hardly any doubt that space is filled with great numbers of objects that are dark and not easily noticeable. There may be wandering black holes among them. These mysterious objects roaming around in interstellar space and absorbing every bit of light they come across will probably never reveal their secrets to us. Long before telescopes had been invented, people could observe a light strip crossing the heavens. The fascinating and mysterious phenomenon prompted a multitude of legends, but it took thousands of years of scientific progress to finally account for it. It turned out that the Milky Way wasn't a path of gods. What it is the dissipated light of billions of stars too remote to distinguish each one separately. The idea of the stars around us making up part of a single structure of enormous dimensions was first suggested by Immanuel Kant back in 1755. He also assumed that some nebulae discovered by scientists could in fact be remote star clusters, that is, other galaxies. This ingenious guess was well ahead of its time, with the philosopher's contemporaries initially dismissing it. Only in the early 20th century did the progress of observation equipment enable scientists to confirm the existence of other galaxies, and in 1936, Edwin Hubble devised a classification system. Many of its principles are still referred to by scientists today. According to the system, the Milky Way falls into the category of barred spiral galaxies, although it took a long while before it had assumed its today's looks. Our galaxy is quite an old one, since the stars in its central globular clusters were born as far back as around 13 billion years ago. At the same time, there are some areas in the Milky Way where stars are actively born, which means that there is always a fresh supply of young stars. The collected data points to the fact that the Milky Way is a comparatively large galaxy in astronomical terms. The diameter of its disk measures as much as 200,000 light-years. With a halo reaching out into space much deeper yet, our galaxy is home to at least 200 billion various stars, as well as 25 to 100 billion brown dwarfs. In addition, it contains over 1 trillion planets, countless small celestial objects, as well as clouds of cosmic dust and interstellar gas, which may reach gigantic dimensions. At the same time, regular matter accounts for a small ratio in the galaxy. Around 90% of the Milky Way's overall mass is the so-called dark matter. The amount of light emitted by this mysterious and widespread substance is negligible. However, dark matter plays an active role in gravitational interaction. Even though most of the galactic mass remains invisible, we can still calculate it. To that end, scientists refer to stars' trajectories of movement around the center of the Milky Way. According to the estimates, the overall mass of our galaxy reaches 0.8 to 1.5 trillion solar masses. The structure of the Milky Way is quite elaborate. We'll start our journey today from its center. This area of the galaxy is shrouded in massive clouds of gas and dust, but by a happy chance we can observe it through the so-called Bardes window, an area of space with lower amounts of dust. Just like most spiral galaxies, the Milky Way has a supermassive black hole in its center, which is surrounded with an accretion disk with a radius roughly 3 light-years. Dubbed Sagittarius A star, it is the closest object of this class to us. Its mass is 4.3 million solar masses, and its radius isn't over 16 million kilometers, which is 3 times smaller than Mercury's orbit. The first data about the nature of the object in the center of our galaxy was acquired in the course of long observations and thorough calculations. Only as recently as on May 12, 2022 was it possible to get the first image with the help of the EHT network of radio telescopes, and so the earlier hypotheses were confirmed. The area in the center of our galaxy is highly populated. More than 6,000 stars have already been detected within 3 light-years from the black hole, with the orbits of some of them defined rather accurately. For example, there is a white-blue star, designation S62, which is 17.8 astronomical units away from the black hole on its closest approach to it, while moving at 6.7% the speed of light. Classical mechanics laws are inadequate for description of the trajectory of movement of a star as swift as that because of relativistic effects. Just to illustrate, the axis of its orbit shifts by 75 angular minutes with every completed orbit. Besides, when crossing this area in space, we can see several large star clusters with a total mass of around 1 million solar masses. And slightly further, roughly 200 light-years away, another massive black hole is likely to be lurking, whose mass should be around 100,000 times that of the Sun. Traveling further on, we will reach the central molecular cloud, an irregularly shaped area measuring 1600 to 1900 light-years, whose mass is over 60 million solar masses. There are a great many stellar nurseries and gas nebulae, as well as protostars and remnants of supernovae. Most of the cloud's matter is dense hydrogen, whose temperature fluctuates between 50 and 600 Kelvin, which corresponds to 223 degrees Celsius below zero to 327 degrees Celsius above zero. Spectral analysis shows the gigantic nebula to contain carbon monoxide, methyl alcohol, and hydrocyanic acid in addition to hydrogen. Having receded from the Milky Way's center a bit, we will see that it is encompassed by a bulge, a bright and massive formation of an elliptical shape. With its length reaching 10,000 light-years, its transverse diameter is roughly 7 light-years. The total mass of the bulge is as much as 10 billion times that of the Sun. The exact number of the stars cannot be calculated because their radiation blends and renders any estimates unrealistic. Being elongated, the bulge forms the so-called bar stretching for approximately 13,000 light-years and serving as the base for spiral galactic arms. It is here, at one of its ends, that we can see the star cluster Stephenson 2, containing the largest known star today. Its designation is Stephenson 2-18, and its radius is 2,150 times that of the Sun. Unfortunately, chances of finding exoplanets orbiting this outstanding object are quite minuscule. Even if planets did exist at some point in the past, the hypergiant would have swallowed them up while it was expanding. The galaxy's center is home to billions of stars and apparently a great number of exoplanets. Chances of encountering a potentially habitable world among this great multitude are much lower than in less populated areas of the galaxy. This is due to the fact that when a big number of stars are located close together, they destabilize exoplanets' orbits, while their powerful radiation is lethal to all living things. That is why a special area in the galaxy is defined as the habitable zone. It looks like a ring, with a radius measuring 22 to 29,000 light-years, and contains star systems with the most favorable conditions for the genesis of biological life. Worlds encompassed by the ring languish in exposure to excessive radiation, while beyond the ring there's a lack of heavy elements. However, mathematical modeling shows that stars within galaxies are able to migrate thousands of light-years away, thus either leaving the habitable zone or entering it. Consequently, with an exoplanet lying within the zone, it does not automatically suggest favorable conditions on it. Moving on away from the center of the Milky Way, we will have a chance to check out its most impressive part, the galactic disk. It is made up of two components with different properties. The first one, known as the thin disk, measures 1000 to 1300 light-years in thickness, and its visible radius measures as much as 50,000 light-years. On the edge, it gradually dissipates, with the outermost stars lying up to 100,000 light-years away from the galaxy's center. This part of the Milky Way contains around 80% of the galaxy's visible mass, and in fact, it was the last component to have formed. As for the thick disk, its diameter is comparable to that of the thin disk, but is 4 times as thick and is much more rarefied. It is made up of old stars and is practically devoid of interstellar gas. Observations of some stars in the Milky Way, as well as mathematical modeling, show our galaxy to have swallowed up another one in the period from 11 to 8 billion years ago. This hypothetical cosmic structure was dubbed Gaia Enceladus. It is thought that it contributed several billion stars to the Milky Way, as well as great amounts of interstellar gas and dark matter. It is thanks to this tremendous event that most of our galaxy's thick disk formed, and an additional supply of gas led to a stellar baby boom. There is no doubt that spiral arms are the most noticeable structural elements of our galaxy's disk. Usually 2 major ones are singled out, the Scutum Centaurus arm and the Perseus arm, and 2 minor ones, the Norma arm and the Carina Sagittarius arm. Sometimes a 5th large arm is taken into account, named after the Cygnus constellation. Galactic arms are areas of especially high star count. Most of interstellar gas is also concentrated here, which is why the rate of star formation in the arms is 3 to 5 times higher than in the galaxy on average. They spend the first millions of their lives in open clusters, but gravity forces are too weak to hold the stars close together for a long time. This destabilizes the clusters, and young stars gradually drift away from each other. Traveling along the Carina Sagittarius arm, we will reach a fork that links it to the Perseus arm. The length of this stellar structure reaches 11,000 light-years, and its width measures roughly 3,500 light-years. It is referred to as the Orion arm, and it is here, 27,000 light-years away from the galaxy's center, that the solar system is located. From our planet's perspective, the galaxy's center is seen as a dark abyss. This is the Great Rift, an area of space that shuts out the greater part of the Milky Way from our gaze. It is filled with massive clouds of interstellar gas and dust, and its total mass is as much as 1,000,000 times that of the Sun. Even though the Great Rift is practically not transparent in the optical range, its matter actively emits radio waves and thermal energy. Spectral analysis data reveals that the clouds are mostly made up of hydrogen with a small percentage of more complex compounds, ammonia, alcohols, and amino acids. The Great Rift is thought to be a potential stellar nursery, but it is going to take a while until the first stars light up in that area. While it is still not quite active, let's move on, beyond the galaxy disk. Even though its bright and clearly defined arms attract a lot of attention, there is more to the Milky Way than that. If we look closer, we will see the vastest and the most rarefied of its components, the halo. Its visible part, spherical in shape, stretches for up to 260,000 light-years away from the galaxy's center, but accounts for just a few % of the total mass. The halo contains a great number of globular clusters made up of remarkably old stars over 12 billion years of age and several tremendous stellar streams. The Sagittarius stream, for example, made up of several thousand stars, encompasses our galaxy in an elongated ellipsis, which is almost perpendicular to the main plane. Modeling shows that all these stars are highly likely to have been gravitationally captured by the Milky Way from a dwarf satellite galaxy. Designation Sagittarius DEG. It lies 500,000 light-years away from the Milky Way's center and is going to be swallowed up by it completely within several billion years. Another dwarf galaxy has already met a similar fate. Lying in the Canis Major constellation, it was almost destroyed by the Milky Way, which pulled out millions of its stars by gravity forces. Stretching for 200,000 light-years and mixing with other stars, this string of stars with a total mass of roughly 100 million solar masses has already wrapped around our galaxy 3 times. Apart from bright but rare stars and clusters, the halo contains great amounts of gas, whose temperature reaches millions of Kelvin. Also, great amounts of dark matter are thought to be scattered in the vicinity of the Milky Way, forming the so-called dark halo. Stretching for up to 2 million light-years, it hardly emits any electromagnetic radiation and can be detected only by gravitational interaction. The dark halo remains an unsolved mystery, yet it greatly contributes to the global stability of our galaxy. The diversity of space objects is truly fascinating. With some of them spread all over the place, others are absolutely unique. Every corner in space harbors countless mysteries, and whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show. And whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show.